I'm Liam Crilly. I'm Director of Product Management at NGINX, and welcome to the only talk that's not about web. So just to be sure you are in the right place. So we won't see much HTTP in this talk, but we will see Stream, we will see nginScript, and we'll see some MQTT. Right, but first, a hockey stick, right? Because this is an IoT talk, it's Internet of Things. You can't have an IoT presentation without a hockey stick, because depending on which analyst you speak to, their predictions are between 1 and 50 billion IoT devices by 2020. So whichever way you look at it, we're talking about a whole lot of data from a whole lot of things. Now, every year, we ask our open source community and our NGINX Plus customers what they think of NGINX and how they use it. As you'd expect, the vast majority of use cases are for HTTP functions, applications, all the good stuff you do with NGINX today. But as you can see, as you can just about see, 58% of our NGINX Plus customers are also load balancing TCP and UDP applications with NGINX Plus. And now 10% of NGINX Plus customers are also using NGINX for their IoT applications or IoT projects. Now, can I get a show of hands? Anyone in the room using NGINX for load balancing layer 4, using Stream, TCP, UDP? All right, I'll call that 25%. What about IoT today? What about IoT in the future? All right, so okay, it's not a hockey stick, but it's on its way. Now, we're not the only people doing surveys, and the Eclipse Foundation, they ask their IoT community every year a whole bunch of stuff about their IT projects. And this question is particularly interesting to me. What messaging protocols do you use in your IT project? And no surprise to see HTTP up at the top of the list, but it's also fair to say that MQTT is leading the way in terms of IoT-specific messaging protocols. And CoAP is gaining popularity as well, up 5 points in the last year. So we're seeing some momentum there around CoAP as well. And of course, both protocols can be proxied and load balanced with NGINX. And it's as simple as this, right? We have a stream block for our layer 4. In that, we put an upstream group, just as you would for HTTP. Define our upstream servers, what IP, what ports they're running on, and then have a server block for our front end, specifying a listen port for the protocol. So MQTT defaults to 1883, CoAP defaults to 5683, and you'll notice that we use the UDP parameter to the listen directive to specify when we want to listen on UDP, TCP being the default, right? And then we proxy pass anything that comes our way to the backend, to the upstream group, right? And so if you want to put NGINX in front of your MQTT or your CoAP servers, this config will get you started straight away. This is all you need. But this talks about how to load balance MQTT, so let's get into that. Right. MQTT is a pub/sub messaging protocol. So with MQTT, you have a broker, middleware, acting as a routing agent for messages. And then you have clients. They can either publish messages, subscribe to messages, or do both. And the reason I think why MQTT has become so popular for IoT projects is that it's simple, right? It's simple, but it's as complex as it needs to be. Messages are very compact, and therefore it uses the network very efficiently. And that kind of reminds me of NGINX, and I think it's a really nice fit. So you'll be pleased to hear that this talk has some live demo content. So it's exciting for you, it's exciting for me, especially because I wrote some code for this. It's kind of buggy still, and we may need to do a restart. So It's going to be fun. We'll see how we go. But first things first, we're going to just do some basic load balancing, and we're going to use health checks. And it's kind of simple. We look at the config we had before. MQTT is a binary protocol, right? So after we've specified our server block down there, we have also specified a health check. And by default, specify a health check with NGINX Plus. It will check that the port on each of the servers is available, a TCP handshake. But that's not good enough. We want to do better than that. And we want to make sure that when we do a health check, we're checking that the upstream server is actually capable of handling MQTT traffic. So what we're actually doing with this health check is we specify a match parameter to a block called MQTT connect. And that has a send and an expect. And this will put a string onto the network to each of the servers. And as a binary protocol, we've encoded it here as a hex string. The send is an MQTT connect packet, as any other MQTT software will do. And the expect is for the response to that, which is a connection acknowledgement, a CONAC. Now, the hex there looks a bit hairy. Actually captured that using TCP dump or Wireshark. But the MQTT protocol is sufficiently simple that we can construct the expect statement as those 4 bytes right there just by looking at the spec. And this is how I did it. So byte 1 is 1 at bit 5, so that's hex 20. Byte 2 is 1 at bit 1, that's 02. Right? Byte 3 in the variable header is going to be 0 to establish a clean session. So each health check is going to look like a brand new connection to the MQTT broker. And then finally, byte 4 is the connect return code. And 0 means connection accepted. So if we get a 0 in byte 4, we know we're good. Now, it's possible for the MQTT broker to be up and healthy, but still respond with a 1 to say that it's unavailable to accept new connections. Say it's too busy, for example. So it's important here that we're defining a health check where the successful response is to say that I can accept a TCP connection, I can handle your connect, and I'm going to say that I'm able to receive more connections. So that's the setup. Let's move on to the demo. Now, as I said, I wrote some code for this, and some of it was in C, which makes it even more hairy. So I'm just setting expectations. It might not go smoothly. Before I can show you NGINX Load Balancing MQTT, I kind of need a whole MQTT IoT environment to do that. I don't have a dozen Raspberry Pis in my bag I'm going to pull out and stick on the desk, and I don't have a wireless network because that's doomed to failure, and I don't have an MQTT broker in the cloud. So I'm going to build a bunch of stuff on the website, on my laptop. For MQTT cluster, I'm going to be using VernMQ. It's just one of many open source MQTT brokers out there. I chose VernMQ in particular because you can set up a cluster with Docker images, and it took me about 90 seconds, and that makes it pretty awesome in my book. So that's what we're using for the MQTT side. And for the, I'm also going to need some IoT devices, right? Some things. And for that, I'm using Contiki. Contiki is a real-time operating system for writing applications on constrained devices, little modes, little sensors. And the cool thing about Contiki is it also comes with a simulator tool where you can run and compile your code before you push it onto the real physical device. So I'm just going to use that, and we'll see what that looks like. And it gives me a network and a radio and all kinds of cool stuff. So let's also look at my, so this is my IoT device, my thing, right? So it's got a light sensor, a temperature sensor, giving out some fake values, and it's got a wireless network. And all it's designed to do is hardwired to make an MQTT connection to my NGINX instance, to publish its sensor data routinely, and to receive commands, so it subscribes also to topics. So it's got two-way communications to the broker. And as we saw before, this is what it's going to look like. I've got my devices. I've got an edge router which allows the network to flow through onto my regular network on my laptop, and I've got my NGINX instance in the middle. The NGINX instance, in this case, it could either sit as more of an edge server to help these devices get to the IT platform, or it could sit as a front-end load balancer closer to the IT platform itself. It doesn't really matter. Your use cases vary. It works pretty well in both kind of scenarios. So, with that said, this is where it gets exciting. So, first of all, I have just need to find out where my mouse went. There we go. And if this is too small, we will make it bigger. And let's first, I'm going to need to make sure NGINX is running. It wasn't. Now it is. So our health checks are all failing. Everything is red on the NGINX Plus dashboard. So let's get a couple of nodes of the cluster up. Docker image 1, Docker image 2. Let's see if they're running. They're running. Let's see if the cluster is good. Not yet. There we go. 2 nodes in the cluster. That's pretty cool. So we should see the dashboard start to be a little bit less red. Now we've got a couple of our MQTT brokers are up and running. And that should be enough to start moving some traffic around. So now let's get the sensors up. They are here. So this is Argon. This is where I'm going to run my sensors. I'm going to load a simulation. So this is a Java app that implements the Kentucky RTOS. We're going to compile it, and it's got these 3 different types of sensors, right? We've got our edge router on this Bluey chipset. We've got a small sensor with temperature and light, as I mentioned. This one, the blue one, has an HTTP interface, so we can use the web browser to go see it. And we've got an MQTT sensor on this red chipset board here, and we're going to see all these 3 in action. So we've got these 2. This is my edge router in the middle. Let's start the network, and we'll boot up. They'll find themselves an IPv6 address, and they are ready to go. So if I start a web browser, point it at that IPv6 address. So there's the router ending 101, and it can see it's got a neighbor and a route 202. So let's go to that IP address, and it's a sensor. It's got HTTP interface, and it's telling us what its light and its temperature readings are. So that's great. Let's make the MQTT stuff happen. I'm going to add some MQTT sensors. I'm going to add 4 for fun, and I'm going to put them closer to the router, because this is a lossy radio network and it tends to go a little bit ropey if they're far away. Okay, so let's start that up again, and they will boot up. They'll get an IP address on the network, and because this is the first time I'm doing it live in front of people, we're going to get a stack trace. So let's just do that all over. Yeah, so we've seen these guys. Let's add the MQTT guys again. I'm still going to do 4. And they're going to be closer together. Real close. Get near to the router. All right. Then we're off. Registering on the network. And as soon as they're registered, they're going to try and connect to that hardwired address, which is the NGINX instance. Okay, so that looks a bit better this time. Let's go back to the router web UI and see if it can see them. All right, so we've got IP addresses that end now 3, 4, 5, and 6. There are MQTT devices. They are on the network. I'm going to go to my laptop shell here, and I'm going to use, this time, the Mosquito MQTT client, which is command line, so it's really easy. I'm talking to Oregon here, port 1883, and I'm subscribing to this topic, and we've got sensors 3, 4, and 5 have come online, and they're pushing to the broker. I'm pulling from the broker, and everything is 3, 4, 5, and 6. They're all up, so they're sending data in JSON. They're a sequence number, an uptime, a light reading, and a temperature reading. So things are looking pretty good. Now, we've still got this like down server, right? So let's scoot back over here, extend our cluster. We're going to add a third Docker image as the config was expecting, right? So there's now 3 images running. The cluster has got 3 healthy instances. The health check is passed, and we have an active connection already to our new MQTT broker. So that still hasn't crashed. This is still pulling data. We've got sequence 2, now sequence 3. So everything's ticking along. Beautiful. I'm going to stop that before it stops itself. We'll choose up all my battery. Okie dokie. Right, I'm going to close that down too. Fantastic. So we've got a happy little IoT environment. And that's all great, but real life is more complex. In the real world, IoT devices don't just pop up on a fixed IPv6 address and stay connected forever. In the real world, things are different. And take, for example, a device that moves around a lot. If you're using someone else's network, then you can't rely on a static IP address. If you're using GSM or LTE, in particular, these networks are going to be, as you move around, you're going to pick up new IP addresses the whole time. And in this situation, session persistence is extremely useful, so that when you reconnect the same device, you get back to the same MQTT broker in the cluster that you were previously connected to. And this means less work for the MQTT broker, or for the cluster, in fact, because a reconnecting client then doesn't have to have state synchronized between the cluster unnecessarily, or have data shuffle around. So this is the scenario. Our vehicle initially connects with the blue IP address, then it moves around, then it reconnects, this time with the orange IP address. Now, both times it was connecting with a clientId, which is part of the MQTT spec, a mandatory element to identify the device. That stays the same. So what we want to do is have NGINX. In fact, we want to extend NGINX so that it uses the clientId to make the load balancing decision, so we have session persistence to the same broker. And with nginScript, we can add protocol awareness and layer 7 functionality for MQTT. nginScript is a dynamic module for NGINX and NGINX Plus that implements a full JavaScript VM for each TCP connection, or UDP connection, or HTTP connection. It means that you can extend the functionality of NGINX by writing regular JavaScript code. And let's hook all that together, and we'll see it in action. So this is pretty much the same config we had before. Only this time we have the JS include directive, which means we're going to pull in some JavaScript code from a file called mqtt.js. All right, that's it there. Brace yourselves. Here it comes. Yeah. Okay. So it's 20 odd lines of JavaScript. I won't expect you to read it, and hopefully it's too small that you can't read it. Right. At the top, we've got a get client ID function, and this is called at the pre-read phase with the JS pre-read, and that means that we run this code before we proxy, before we load balance, which means that we can get the information before it's needed. Right, so what happens here is that we set a client ID str variable inside which is a global variable defined right at line 1 in the JavaScript code, so that when we use the hash directive, you see here, it's looking to hash on MQTT client ID. And MQTT client ID is defined by the JSSet directive, which calls this little function at the bottom, which just exposes the JavaScript variable as an nginx variable. So this means every time we receive a new MQTT connection, we look inside the packet, we parse the MQTT, we grab the client ID variable, we make it available to nginx, and then we hash that value against the 3 possible MQTT brokers that we have available. So for the same client ID, we'll always select the same upstream server. And we can see that working, right? So the one thing I'm going to do first of all is just edit this proxy timeout so that so the NGINX closes idle connections, and we'll see some log values. So I've got logging for MQTT. We'll reload NGINX. Alrighty, everything is up, and this time I'm going to be looking in the access log. So we'll just restart this simulation again. They're going to fire up and do exactly the same thing as before. It's going to work. And this takes a, yeah, so one more time. All right, get closer and start. All right, they're all connecting. Not the most reliable. And with any luck, once they've finished establishing some sort of connection, they will start talking to NGINX, and NGINX will start logging the TCP connections. Yay. Right, that's the first one. Right, so you can also use the variable that we exposed in the NGINX config as part of a log format, which means that every time we get a connection from a device, we're logging it, and we can log, as you see here, the clientId value. And what we can see here is that sensor 4 likes to connect to node 2, one that is listening on port 18832. And should we see any other sensors come online, we'll see where they get hashed to as well. But the important point here is that when the same device connects, it will always go to the same backend. There's sensor 3, it likes 32, sensor 4 still likes 32, sensor 5 likes 33. Happy days. All right, I will quit while I'm ahead on that one. And I'll put this back the way I found it. All right. Okay, on with the show. All right, TLS. So why do we want TLS? Well, securing data is one of the big problems facing IoT projects. Adding TLS seems like a no-brainer, right? So why use NGINX for that? I mean, all of the MQTT brokers, at least the ones I've come across, they support TLS. So we can use that. But, well, all the web application servers that I've come across, they support TLS as well. And generally speaking, it's best practice to try and offload that to a front end, to a reverse proxy, to a load balancer. So same holds true for IoT traffic and IoT as well. And I'm not just picking on VernMQ here. It's kind of it's the same for everything. If you are performing TLS on the broker will consume more resources. For best performance, let the broker do the brokering, offload as much as you can to the front end, and that way you can scale the load balancer for network and crypto throughput, and scale the broker for clustering and messaging throughput. So what we're going to do is use TLS, but you can turn TLS on for all connections. Our vehicle has enough compute power to handle TLS, but my little battery-powered sensor on a little chipset, that can't. So being pragmatic, what I'm going to do is I'm going to set up selective TLS. I'm going to have plain text on my device network. These are the guys, all they're doing is pushing data up. But on my internal network, where I've got a client application, if I want to send connections, then I'm going to have NGINX listen on the MQTT secure port 883. and I'm going to have TLS on there. And not only am I going to have TLS for data encryption, but I'm going to use X509 client certificates to authenticate the application to the broker. And there's an app for that. So let's first look at the config. So to do the selective TLS, it's as simple as splitting our server block into two. So I've got, this time I'm being specific. I'm listening on the IPv6 address on port 1883 as before, and I'm listening on my IPv4 address on the internal network requiring port 8883 and SSL parameter so that we are going to do TLS. And then there's a bunch of SSL directives that I don't need to go through here, but we're going to be specifying certificates, we're going to be specifying cipher suites, protocols, and the client certificate verification as well. And then we'll proxy pass both to the cluster. The actual config looks like this. There's quite a lot of SSL stuff you need to do, but it's all well documented and it all should work. So let's move to the final demo. I'm going to add some blinking lights to my little device, and we'll see if we can turn them on and off. And if we can finish with some blinking lights, I'll be happy. All right. So NGINX is still running. Simulation, I'm going to reload. Oh. With LEDs. Right, so I've got my 4 devices before. Let's get them closer, within range of the edge. And I'm looking at the LEDs for each of them. There's ID 3 and 4 and 5 and 6. And let's start these up. So they're pairing on and they're trying to connect. So they flash green when they're trying to connect. That's not too interesting. So what I'm going to do is show you my back office application. It's called LED on. Check it out. Right, so it's just a mosquito command. This time, using port 8883, specifying my PKI stuff, my certificate, and the topic this time is command, and I'm sending message value 1. Right, that means turn on the red LED. And the demo gods are happy with me. We're published. We got 2 LEDs on, so our 3. Let's see if we can get, oh, look at that, 4 LEDs. And if I'm really lucky, we can make them blink. Yeah, it's good enough for me. Okay. So that's the blinking lights. So this has been about adding protocol awareness for MQTT. We've seen load balancing, active health checks, session persistence using nginScript, selective TLS, and client certificate authentication. It's been a bit of a whirlwind, but I hope it was useful. If you want to get into anything deeper, please come and speak to me right after, or catch me today or tomorrow. So, thanks a lot.
TLS authentication and handshake, because that's a real weak link in the whole idea here. It doesn't really affect the demo or anything, but
yep.
that's a bad thing. If you can impersonate a device, I mean, we've seen some examples of how that can be bad.
Absolutely. So I think
I guess the thing I'm getting at, if NGINX can handle that, it makes the backend, it can handle the handshake and do the offloading. That makes the back end harder. It makes the back end's job easier.
Yeah.
The reason more controllers don't have it is because it's hard on the back
Mm-hmm.
end.
So I think many will, those that have the compute power. I'll repeat the question. So the question is, do I think that we'll see more IoT devices, or all IoT devices, be able to handle TLS? Is that right?
Yes.
So yes, and no. So I think we'll see a lot more. Anything that is capable, I think we will see become capable, just in the way that I think that many that can't today run an IP stack will move towards being able to run an IP stack. Moore's law is almost starting over in the IoT space. So as the cost of chips get less, but there's still going to be these devices that are battery powered that wake up and go to sleep, and I think just either the physical constraints or the power constraints, moreover, will keep those from becoming fully secure.
Smaller certs help that as well.
That's true. Smaller certs, elliptic curve, yeah. So I think we'll see a lot more coverage of TLS implementations, and I think that that's the right way to go. If DIY crypto is always a disaster, so the more that you can, moving more protocols to using TLS rather than trying to wrap up some encrypted payload in some other way, I think has to be the way things move, and therefore you'll be able to do the crypto offload at the front end. So there will be many exceptions, I'm sure, but that's how I see it going. Any questions?
So how much of this demo was NGINX open source? How much was NGINX Plus?
Only the health check was Plus. Everything else.
Good. Everything else I could do in open source.
Yep.
Okay.
All right. Thanks again.